This is the solution to chapter 15 video assignment 1. The question asks, you have a solution that is 0.01 molar chlorine and 0.01 molar oxalate. Your job is to remove the chloride and keep the oxalate. You decided to use selective precipitation with silver. The solubility product constant for silver chloride is 1.87 times 10⁻10, and the constant for silver oxalate is 5.4 times 10⁻12. So you'll add silver nitrate to increase the silver concentration until one starts to precipitate, and then continue adding it until you get just up to the concentration where the other starts to precipitate. So question A is to calculate the concentration of silver ions where silver chloride starts to precipitate. 2 to calculate the concentration of silver ions where silver oxalate precipitates. 3 is once you raise the concentration of silver up to the concentration where silver oxalate starts precipitating, what is the remaining concentration of chloride? And lastly, what is the percent of chloride that is removed this way? So all the pertinent information is written up here, and so we'll just go step by step. So for silver chloride, I just wrote out the equilibrium expression here for solubility product. So the KSP is the concentration of silver times the concentration of chloride. For silver oxalate, it's the concentration of silver squared times the concentration of oxalate. Because oxalate has this -2 charge here, it's gonna, or the resulting species is Ag2C2O4. So it'll be 2 silvers and 1 oxalate. So that's where you get the squared therefore from in the equilibrium, or excuse me, solubility constant product. So for question A, really what we can do is we just use this expression, this equation here for the solubility product. We know the value of this, it's 1.87 times 10⁻10, and we know the concentration of chloride that we have. So the only thing that we don't know is the concentration of silver, and that's what we're looking for, is at what concentration of silver does this start to precipitate. So really we just say that is X, we plug in our value for chloride ions, we plug in our solubility product, and then divide. So for X is 1.87 times 10⁻7 molar silver ions. So when you've added this molar of silver ions, chloride starts to precipitate into this silver chloride. Now we're going to do the same thing for silver oxalate. So same thing, we'll use the equation here. 5.4 times 10⁻12 equals X squared in this case, for the reasons that we mentioned previously, where the silver ion concentration is squared, times the molarity of oxalate, which is 0.0100. So dividing this by 0.01 is 5.4 times 10⁻10, or taking the square root of both sides, leads us to a value of 2.32 times 10⁻5 molar silver. So as we can see here, it requires more silver ion to precipitate silver oxalate than it does to precipitate silver chloride. So essentially what we're going to be doing, we're going to be adding drops of silver, and silver chloride is going to continue to precipitate until it is that the concentration of chloride is so low that this concentration reaches this point. And that's what question 3 is getting at. So essentially we're just plugging this value back into here. We're determining what value of chloride it is that is so small that this equation no longer starts to occur, and this one starts occurring. So we got 1.87 times 10⁻10 for the solubility product equals our concentration of silver at which this starts precipitating, 2.32 times 10⁻5 times X, which is going to be our concentration of chloride, which is what we're looking for, what the question asks. So doing the division here, X is equal to 8.06 times 10⁻6 molar chloride. So when the concentration of chloride is 8.06 times 10⁻6 molar, it no longer precipitates with silver. At that point, all of the silver which is added is going to precipitate with oxalate into this silver oxalate. And so, using this value on our initial concentration, we can determine what percentage of chloride we actually removed doing this. So simple, just our percent removed, an equal sign there, is equal to the molarity concentration that we had initially minus the final concentration divided by the initial concentration. So this is just a change divided by the final times 100. So our initial concentration is 0.001 minus our final 8.06 times 10⁻6 divided by our initial times 100 leads us to 99.2% of the chloride ions were removed by the selective precipitation.